So this is your doodle notes for the last standard in the waves units. This is the properties of light doodle notes. So we're going to talk kind of like we did with all about the sound waves, but now we're going to talk about light waves. There's a lot of things that are very similar between sound and light. Make sure when you do your doodle notes that you have a full set of markers or colored pencils, whatever you prefer. And we need to make sure notes are standing out. So you are actually to color and doodle with your notes. Okay, so let's read this definition. Light travels in the form of electromagnetic waves. There are many different types of electromagnetic waves, most of which we cannot see. Visible light is a part of the spectrum, the electromagnetic spectrum that you can see. So I'm going to go ahead and highlight that section of the notes. So you'll see that we have several different types of light waves. We have radio waves, then we go to microwaves, infrared waves, ultraviolet waves, X-rays, and then last but not least are gamma rays. But I want you to notice the difference between all the waves is the wavelength. So it starts off real long, and then as it increases in energy, the wavelength gets smaller. It is a higher frequency. So these waves down here are actually pretty dangerous. And those waves over here, the gamma rays, will give you cancer. X-rays can do some damage to your body and give you cancer. Ultraviolet rays gives you cancer. All these with high energy actually affect your body. Now, there's only one section of the light that our eyes can sense, and that's the visible light spectrum. It's called visible light because it's visible to our eyes. So right past the infrared is the red part of the visible light spectrum. Infrared just means it's like a little bit lower than red light, the frequency is. And then you have the different colors of the rainbow that we can see. So most people on Earth can see the whole Roy G. Biv, right? About 5 or 6 colors that we identify as part of the rainbow. Really, there's thousands of colors that your eyes can detect. But these are the colors of the visible light. So go ahead and color yourself a rainbow. You're going to end with purple, which is sometimes called violet. And notice the violet's next to ultraviolet. The infrared is next to the red. It's kind of connected there. Ultraviolet means it's past violet. Infrared means it's before the red. So that's the part your eye can see. Some animals can actually detect ultraviolet light. Bees, mostly insects. Some animals, like snakes, they can detect infrared, so they can sense your body heat. It's kind of cool.
Yeah.
Okay, so we're going to write down 4 facts here about light waves. The first one is that they spread out in all directions. So that's our first note. So if you're burning a candle, the candle doesn't go in one way, in one direction. It goes in all direction. The second note, they travel in rays, which basically means straight lines. Light cannot bend. It goes in a straight line, which is why even a piece of hair will create a shadow. Next note, speed. It's pretty darn tootin' fast. Here you go. 182,282 miles per second. That is really, really fast. Nothing else can go with the speed of light that we know of right now. And it can travel through space, which just makes it major different than sound. So it needs no medium. And thank goodness for this, because if it needed a medium, the light from the sun could not get to the earth, because there's nothing in between the light of the sun and earth. There's no air there. So good thing it doesn't need a medium. So let's zoom in right there. Make sure you write those down, pause the video if you need to. We're going to our next section. Okay, our next section is about reflection. Light reflects, just like sound waves reflect and create an echo. When light reflects, it does not have a special name, it's just called a reflection. Okay, so you can see here, we have an iron, or I guess it could be a boat, maybe that's a mirror, and it's reflecting off the mirror. So you see not just one boat, like this original one here, but you see a subsequent boat, a second boat down below. That's a reflection. So let's say you have a flashlight, and it's shining down on a flat surface, the light will bounce back. And that angle does match. You're going to watch a video later about the angles of light as it hits it and the angle as it bounces back. So here's our mirror, flat surface, reflecting the light. So here's our definition of reflection. The way light interacts with an object is dependent on the frequency of the light and the nature of the atoms in the object. So not all surfaces will create a reflection, but many flat, smooth surfaces do. And even though this paper looks smooth, I cannot see my lovely face. You cannot see my lovely face in it because at the atomic level of the atoms, it's not perfectly smooth. So we're thinking things that create reflection would be like mirrors, water, windows. Those are things that create a reflection. So in this area right there below, you need to go ahead and doodle yourself an example that you see when you look at it, you see a reflection of yourself. So in this area in there, you should be doodling a reflection. It should be something where you can see the original image and the subsequent image, the reflected image. So I'm going to go ahead and draw my picture, and it's going to be, oh, it's going to be glorious. I'm looking forward to having some spring break coming up, and maybe my kids have spring break the same time I have spring break. We can all go to a lake with some trees, and then we can look at this lovely lake. Look at that, gorgeous. And we can see the trees reflected in the water. And it'll be so calm and peaceful because there's no work, you know? It's just us and Mother Nature and maybe some random red bird. And we see the red bird reflected right there. It looks like it could be red bird, it could be black, I don't know. So, my example is a reflection on a lake. On a lake. Okay, one more section here. It's kind of reiterating a different type of reflection. So I talk about echoes. Don't want to spend too much time on echoes since we already talked about sound waves and how they reflect. That causes a lovely echo. So we'll just go over this quickly, but this is the previous standards work. It's kind of cool because you're going to see the original sound coming out of the words echo. And it hits an object. Maybe that object is, I don't know, a wall or something. And then it bounces back to the person. So you can hear the sound again. So an example of that would be if I'm stuck between a rock and a hard place, we'll make these two mountains. We gotta get some snow on top of the mountains. Mountains always has snow on top, right? So there's my mountain 1, mountain 2. And let's say I'm here on top of a glacier and I'm red. I'm in between the two mountains. So I'm gonna shout out, "Ah, Ricola!" That was a commercial from when I was a kid. And then the echo pops back and I could hear, "Ricola!" That would be an echo. I forgot to get myself here. Ah, I'm gorgeous. Okay, so now you need to turn your paper over. I'm going to go ahead and use a second. Oh no, it doesn't bleed through, so I'll just use this paper. Okay, so we have reflection. Light is reflected. When light's not reflected, sometimes it's actually transmitted. So I'm going to label that. That transmission, it's kind of like with sound waves. When sound wave is transmitted, it goes through something. And with light, sometimes it goes through things, sometimes it doesn't. It depends on the particles of the object. So our definition is when light passes through matter. So light travels through some materials more easily than others. So there's 3 types of material that we're going to talk about. The first one is if this is transparent. Sometimes I can tell your motives are very transparent. I know what you want. You know, I can tell by the way you ask for something what you want from me. So that means you're being transparent. Now, something that's transparent in real life, if I can see this hand perfectly through the object, will be if I'm looking through a window. Most windows that are clean are transparent. So I'm going to go ahead and label this where I see that person's hand completely through it. This is a window. Okay. Now, the next one, there might be a new word for you. I'm not sure. It's called translucent. Translucent is kind of sort of see-through. So this hand is going to be through there, but it's going to be kind of blurry. It's not going to be just like the original. You can see part of his arm down here. It's kind of blurry. You know, I have a few translucent objects in my house. Our shower doors are kind of sort of see-through. You can tell there's a person in the shower. You can tell they're holding a green bottle of shampoo, but you cannot see all the nooks and crannies of that person in the shower, right? They're fuzzy shower doors. Our car windows also have like tint on them. It doesn't let all the light through, it lets some light through, so I can't be seen exactly if I'm giving the next driver a dirty face. So let's write an example up here. So this would be like a fuzzy shower door. In the second activity you did for the standard, you also used some wax paper. Wax paper is kind of sort of see-through. Okay, so what translucent objects do is it scatters light as it goes through. The transparent stuff, it lets all light through. My glasses are completely transparent. It's letting all the light through. But the translucent stuff scatters some of that light. And then we have the last one. It's a funny word. Opaque? No, it's not opaque. It's called opaque. So if something is opaque, you cannot see through it at all. So I see that the person's hand is still hanging out down here. There's his arm. But I cannot see his hand at all. it appears to me that this is maybe some foil or something, and I can't see through it. It's completely opaque. So opaque is how you say that word. Things that are opaque. Most of the time, your clothes are opaque. Thank goodness. We did not want to see through your clothes, and usually they're not shiny, so they're not getting any reflection. It's a brick wall is opaque, and this paper here is opaque. You cannot see through it. So it either reflects light or it absorbs all the light that hits it. Or it does both. So it reflects the light that hits it or it absorbs the light that hits it. So that's opaque. Cannot see through it. So like this hand does not exist anymore. Okay, so we have 2 more sections left. We're on refraction. That's a funny word. Not reflection because it has that R hanging out in the middle. So this is refraction. Refraction is probably a new word for you. I don't believe you've learned it from other things. So if you look at this graphic that they have here, it hits a surface, and maybe the surface is water. Water does a good job at doing this. And then as soon as it hits the water, it bends. So let's read that definition. It says that light changes direction slightly when it passes from one material to another. So let's use this water cup first for an example. You can see this everyday life. If you have a water cup at home, you grab a straw. It needs to be a clear glass cup. And it looks like, oh my goodness, it's magic. The straw was going in one direction, and all of a sudden it's in the water. It sometimes looks magnified and bent. It's what makes it harder to just reach into water sometimes and grab something because it looks like it's in one spot, but really it's in a different spot. The light is bending and going in a new direction. It kind of plays tricks on your eyes. So the direction of the bend has to do with whether the light speeds up or slows down when it passes through the material. It reminds me of when my kids were learning to ride their bikes, and sometimes they would go from the sidewalk to the grass, and that slows them down, and they would veer off course. So changing speed caused them to change direction also. So here's a prism. As light from maybe a flashlight, or maybe this is from a candle. As that candlelight is burning, it's called white light because it has all the colors of the rainbow, and as it goes through the prism, it's also how raindrops work. They separate out and form the rainbow. So sometimes you'll see with prisms, you can see a rainbow through it, or you can see through a raindrop, you'll see a rainbow form. That's because the light that's going through that raindrop is being separated by the different colors, the different wavelengths. So that's refraction when light is bent. So here, let's think about this. I'll write it in a bright color. Let's use pink. The light was going through air here, and then it started to bend when it was going through the glass prism. So the light was going, in this one over here, the light was going in the air, and then it started to bend when it entered the water. So it's a new medium that causes it to bend. Okay, last one, absorption. So absorption is the last thing that light can do. Light can be reflected. Light can go through things, transmitted. Light can refract, or light can be absorbed by an object. So if you look at that graphic here, it's hitting this surface, and this surface is sucking it all in. It's absorbing it all. Okay? So let's look at our definition. When the atoms in the matter absorb light, the absorbed light is converted to some other form, usually thermal energy, aka heat. It heats up. So if you're wearing a black shirt, if you have black hair, sometimes that black absorbs it and makes it hotter. Okay. So let's think about this apple here. Apples are typically red, so let's go with a nice red apple for this example. I prefer the green ones myself. When the light hits the apple, it's coming from the sky, and it has all the colors of the rainbow in that light, the white light. Well, you know what, my friends? All these other colors are being absorbed by the apple. It's absorbing the blues, it's absorbing the greens and the purples. It is absorbing the yellows and the oranges. But the red apple does not absorb that last color. It does not absorb red. And that red is bounced off to your eye, and therefore you see the red apple. It's supposed to be an apple there. So that's kind of creepy, huh? Okay, see, there you go. It's in his eyeball. So you see the red because the red is bouncing off that red skin and going into your eye. All these other colors are being absorbed by the pigments in that apple. So why does the apple appear red? The apple absorbs all the other colors and reflects red to our eyes. For instance, you see orange here. Every other color from my light is being absorbed in this little arrow, but your eyes are seeing the orange that's bouncing off that colored pencil there. So what color you see is the color that's bouncing off. So a yellow colored pencil, yellow is bouncing off to your eyes. Every other color is absorbed here. If you see a blue marker, the blue is bouncing off into your eyes. So whatever color you see is what's entering your eyes. Okay, that's it for your doodle notes. Please put away your markers and place this into your notebook. And we hope you have a good day. Bye-bye.